Hi, welcome to the Corbettmaths Ultimate CA M6 revision video. In this video we're going to look at the M6 topics from the CA GCSE Maths list, so we're going to go through those M6 topics. Make sure for M6 that you do know the M5 topics as well as the M2 and M1 topics as well. Now M6 has a non-calculator as well as a calculator paper, so make sure the topics from M1, M2 and M5 that may be typically non-calculator topics such as adding fractions, multiplying fractions, dividing fractions and topics like that you're fully confident with those. Okay, so in this video we're going to go through these M6 topics. So in green we've got the geometry topics, so the shape, space and measure topics. In blue we've got the algebra topics. In orange we've got the statistics and probability topics, and in red we've got the number topic. And so these are the M6 topics we're going to go through in this video. I'm going to spend about 3 or 4 minutes going through each of them, so the aim of this video is to make sure you're familiar with each of these topics. If you do need any further help on any of the topics, in the description below there's a link to this checklist. And in this checklist, beside each topic, you've got the video numbers from Corbettmaths which go through each topic in a bit more detail. And also, to accompany this video, we've got the Ultimate CA M6 revision question booklet. Catchy title, I know, but this booklet has a question on every single one of these topics. So as I go through this video, you can make notes in each of the topics, but also there's questions to practice as well. And if you want to check the answers, if you scan the QR code on the front of that booklet, you can check the answers as well. Now in this video I'll be borrowing some of the Corbettmaths revision cards. The Corbettmaths revision cards are very useful to help you with your study for M6. So if you're studying for M6, I would highly recommend the foundation set, and in this video we'll be borrowing some of those, and if you want a set yourself that you can go through and use for your studies, there's a link in the description below to those. In terms of revising for M6, rather than leaving your revision just to the end and cramming, I would highly recommend you use a little often approach. So for M6 I would highly recommend the orange foundation booklets. Also, the yellow foundation plus booklets will be useful as well. So those 5 a day, if you spend 5 or 10 minutes every single day with your revision, it'll really help you out. Okay, so let's get started. So our first topic is bearings, and here's a typical bearings question, and bearings is video 26 on Corbettmaths. So if you do want that full video talking through bearings, if you watch that video 26 on Corbettmaths, it'll go through bearings in a bit more detail. But as I said, the aim of this video is to spend about 3 or 4 minutes on each topic to make sure you're familiar with the topics. So here we've got 2 towns, we've got Antrim and we've got Belfast, and the question says write down the 3-figure bearing of Belfast from Antrim. So bearings are a direction of travel and they're measured clockwise from north. So in this question we've been asked to write down the 3-figure bearing of Belfast from Antrim. So if I was asked to do that, the first thing I would do is get a ruler and pencil and join up the 2 towns. So I would join up Antrim and Belfast like so. Then next I would draw a north line at Antrim. So I would just get a ruler and pencil and I would draw a north line going upwards from Antrim like so, because that's where we're measuring the bearing from. It's the bearing of Belfast from Antrim. So there's our north line. And I'm just going to put a little N beside it just to show that it's north. Next, we want to mark in the angle that we want to measure. Now, bearings are measured clockwise from north. So the bearing will be this clockwise angle going around from the north line to the line joining Antrim and Belfast. And we're going to get our protractor. So we're going to get our protractor and we're just going to rotate it. So we've got our protractor and we're just going to put it on top of Antrim. So we've got the cross of it on top of Antrim. And we've got the 0 going along the north line and we've got 0 on the top. Now the bearing is measured clockwise from north, so we just need to measure this angle. So we've got 0 at the top, so we're looking at these outside angles, and we're going to start from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and then we've got 101, 2, 3, 4, 5. So that is 105 degrees. So if I move my protractor, a 105 degree angle, and the question said write down the 3-figure bearing of Belfast from Antrim, so the answer would be 105 degrees. Okay, let's have a look at another one. So we've got 2 made up towns here. We've got Castletown and Milton, and we've been asked to write down the 3-figure bearing of Castletown from Milton. So again, our first step is to join up the 2 towns. So get your ruler and pencil and join up Milton and Castleton like so. So we've joined up our 2 towns. Next we want to just make sure we know where we're measuring the bearing from. So we want to measure the bearing of Castletown from Milton. So we're in Milton. So let's draw our north line at Milton, and we'll just put a little N at the top to show that it's north. Next, let's get our protractor and we want to rotate it so that we've got the 0 at the top. So we've rotated our protractor, and now let's just double check with the angle we want to measure. So we want to measure the angle going clockwise from north. So marking in the angle, it's clockwise from north. So that's the angle we want to measure. And we're going to get our protractor and we're going to put the 0 on the north line and the cross on Milton. So let's now measure our angle. So we're starting at 0, so it's 10, 20, 30, 40. And as you can see, we haven't reached 45, so we've actually got 44 degrees. So that angle is 44 degrees. So let's just move our protractor and mark in that it's 44 degrees. So 44, degrees. And we've been asked to write down the three-figure bearing of Castletown from Milton. But remember, the bearing has to have three figures, so it's going to be 0, 4, 4 degrees. We're just going to put a 0 in front of that, so 0, 4, 4 degrees. And that's it. So the bearing of Castletown from Milton is 0, 4, 4 degrees. That's it. Okay, our next question. Okay, this time we've been asked to write down the three-figure bearing of Portrush from Larne. So this time, we're going to join up the towns as before. So we've joined them up. Now we're going to make sure we know which way north is. So north is going upwards, and we want to just check where we're starting from. So it's writing down the three-figure bearing of Portrush from Larne. So we're in Larne, and we're going to do our north line at Larne. So there's our north line, and let's just mark it with a little N. Now we've got a mark on the angle we want to measure. So remember, bearings are measured clockwise from north. So we want to go clockwise from north all the way around to the line joining Portrush and Larne. So we need to measure this angle here. It's a reflex angle, so it's going to be bigger than 180 degrees, but less than 360. So we want to measure that angle. Now there's three different ways we can measure this angle. The first way is my favorite way. It's actually getting a 360 degree protractor. So this protractor only goes up to 180 degrees. So if you've got a 360 degree protractor, they're actually really fantastic, because you can put the 0 on the north line and you can just go around and read off even reflex angles like this one. If you're measuring this one, what you could do is, one approach is you could actually turn it the other way. So we can measure this small angle here. So we could actually get our protractor and measure the angle anti-clockwise. So it's starting at 0 on the inside, 0, 10, 20, 30. And we're in the middle here between 30 and 40, so that's 35 degrees. So one approach is actually to measure this angle, which is 35 degrees. And because we know the angles in a full turn add up to 360, we could take the 35 away from 360 and do 360 subtract 35, which is equal to 325 degrees. So that means that this angle is 325 degrees, and then that would be our bearing, because it's the angle measured clockwise from north all the way around to the line joining the towns. So our answer would be 325 degrees. So that's one approach. Another approach is to measure that reflex angle, and what we could do is, so answer is 325, we can just go back to the beginning. And we want to measure this reflex angle, so what we could actually do is draw a line straight down, like so. And we know that a straight line, the angles add up to 180 degrees, so we do know this is 180 degrees on the right hand side, so just drawing the line straight down our south line, which would be 180 degrees there. And then we could just get our protractor, and we could turn it around, so that we've got 0 at the bottom this time. And we want to go from 0 around to where the line is. And as you can see, if we start at 0, which is at the bottom here, we've got 0, 10, 20, 30, all the way around to in between 140 and 150, and it's in exactly the middle. So that means that's a 145 degrees. So if we wanted to measure this clockwise angle, this reflex angle, we know that we've got 180 degrees and another 145 degrees. And if we add those two together, we also get 325 degrees. So that's it. So the bearing measured clockwise from north, from Larne to Portrush, would be 325 degrees. Okay, let's have a look at our next topic, and that's actually bearings as well. It's working out back bearings. So in other words, here's an example. If we know the bearing off Nottingham from Dublin as 098 degrees, what's the bearing off Dublin from Nottingham? So going the other way around. So there's two different ways you can actually approach this. The first way is actually just a little sketch. So the bearing off Nottingham from Dublin. So let's do a little X for Dublin. So let's just label that Dublin. And then we've got Nottingham, and it's on a bearing of 098 degrees. So let's put our north line in. And 098 degrees or 98 degrees, if we started at the top and we went around 98 degrees, it would be go past east and just a little bit beyond it. So it means that it wouldn't be here, it would just be a little bit further. So let's put a little cross there and say that's Nottingham. So we've got Dublin and we've got Nottingham. Let's join them up with a straight line. Now let's mark in the angle, so we know that angle is 98 degrees because the bearing is 098, so that's 98 degrees there. Now let's also draw another north line at Nottingham. So we're drawing our north line with the little n at Nottingham, and we want to measure the bearing of Dublin from Nottingham. So we want to measure the angle going clockwise from the north line at Nottingham, going around to the line joining Dublin and Nottingham, like so. So we want to find the size of that angle. Now here we've got two north lines and they are parallel lines. And remember, with parallel lines, the two interior angles are called co-interior. These two angles add up to 180 degrees. And actually, if we go back to our revision cards here, we've got co-interior angles, two angles inside of parallel lines add up to 180 degrees. So if this angle is 60, that angle is 120. So that's quite important. So if we go back to our bearings, we've got, this is 98 degrees. So this angle and this angle here will add up together to give us 180 degrees. So if we do 180, subtract 98, we get, that's equal to 82 degrees. That means this angle here is 82 degrees. Next, we want to find the size of this reflex angle. Now we know the angles in a full turn add up to 360 degrees. So if we take 82 away from 360, we can find the size of this angle. So we can do 360, take away 82. and that's equal to 278 degrees. And that's it. So that means that this angle would be 278 degrees, and that would be the bearing of Dublin from Nottingham. And that's it. Or another way to do it is to actually notice a bit of a pattern. So if you're doing a back bearings question and the bearing that you're given in the question is less than 180 degrees, to get the bearing going the other way, you could just add on 180 degrees and that would give you your answer. And if the bearing you're given in the question was more than 180 degrees, if you take away 180 degrees, you can get your answer. And that's a bit of a shortcut. Now, the way I do that is I visualize it. If I was traveling from Dublin to Nottingham, and then I wanted to go the other way, I would rotate through 180 degrees to go the other way. If you want to watch that in more detail, you can watch video 27A in Corbettmaths, and there's questions there on it as well. Okay, let's have a look at our next topic. So our next topic is angles and polygons, or video 32 in Corbettmaths. And here's the Corbettmaths revision card. Now, in M5, you needed to know what the angles added up to in a triangle, a quadrilateral, a pentagon, a hexagon, and so on. And the rule that every time we added on a side, we added on one over 180 degrees. Now, there's a formula that's really, really useful, and that if you want to find out the sum of the interior angles, or what the angles in the shape add up to, you could use this formula, which is n take away 2, so the number of sides take away 2, multiplied by 180. So for instance, if I wanted to know what the angles added up to in an octagon, I could take the number of sides, which is 8, take away 2, that gives me 6, and then multiply by 180, and that gives me an answer of 1080. Likewise, if we knew what the angles in a shape added up to and we needed to find out how many sides there were, we could work backwards, so we could divide by 180 and then add 2. And that's it. So this formula is really useful, and this is a Corbettmaths revision card, so if you've got that revision card, it's going to be a very important one for you. Okay, let's have a look at a question based on that. So here we've got a question, and it says find the sum of the interior angles of a 12-sided polygon. So a 12-sided polygon, that's a dodecagon, I believe, and we need to find the sum of the interior angles. We need to find out what the angles in that 12-sided shape will add up to. And the formula is to do n take away 2 times 180. So if we take our 12 sides and do 12 take away 2, that's equal to 10, and then do 10 multiplied by 180, that's equal to 1800. So in a 12-sided polygon, the angles would add up to 1800 degrees. Okay, our next example. So our next question says the sum of the interior angles of a polygon is 4500 degrees. So it's got a few more sides than a 12-sided one. And the question says how many sides does it have? So to find this answer, this 4500 degrees, we've taken the number of sides, we've subtracted 2, and then we've multiplied by 180 degrees. So if we want to work backwards, we're going to take our 4500, divide it by 180, and then that will give us 25. But remember, we've taken away 2, so because we're going backwards, we're going to add 2, so we're going to do 25 plus 2 is equal to 27. So the angles in a 27-sided polygon will add up to 4500 degrees, and that's it. Okay, and that's it. Now this formula is really useful. It's really useful for both regular polygons. So regular polygons are where all the sides are the same length and the angles are the same size. And it's also useful for irregular polygons where the angles aren't all the same size. So for instance, if we knew that it was irregular, we could add up the angles that were given and then take it away and then find out the size of the missing one. But if it's a regular polygon, what we can do is, so for instance, with this 27-sided polygon, if we divided 4500 by 27, and we could find the size of each one of those angles. Now there's some other rules with polygons, and they are the exterior angles. So if you've got the interior angle and you carry on that straight line, the angle between the polygon and that straight line is what we call the exterior angle. And I've marked them all on this diagram in red. So all of these red angles are exterior angles. So the sum of all those exterior angles, all of these red angles, will be 360 degrees. So for no matter what polygon you've got, if you add up all the exterior angles, it will always add up to 360 degrees. And then also the interior angle and the exterior angle, because they make a straight line, they will add up to 180 degrees. So there are two very useful rules as well. The sum of the exterior angles, all those outside angles there, all those red angles will add up to 360 degrees. And the interior angle and the exterior angle will add up to 180. So let's do some questions based on that now. So here we've got a typical question. It says work out the size of each exterior angle for a 20-sided regular polygon. So this is a regular polygon, so that means that all the interior angles are the same size, and also all of the exterior angles are the same size. And it's got 20 sides, and we know that all the exterior angles will always add up together to give you 360 degrees. So if we divide 360 by 20, we will find the size of each exterior angle. So if we do 360 divided by 20, that's 18. So that means that each of the exterior angles will be 18 degrees. So we'll have 20 exterior angles and they'll all be 18 degrees each. This time we're asked to work out the size of each interior angle of a 20-sided regular polygon. Now we've got two different ways to do this. We could use our first formula where we take away 2, so that's 18, times that by 180, and that would tell you what the angles add up to in a 20-sided polygon, and then divide that answer by 20 to find the size of each one of those angles. So that's one approach. Alternatively, if we know that all the exterior angles are 18 degrees each, if we take that at 18 degrees away from 180, we will find the size of the interior angle, because remember, the interior angle and the exterior angle will always add up together to give us a straight line, 180 degrees. So if we do 180, take away 18, that's equal to 162 degrees. And that's it. Okay, so our next topic is translations, and that's video 325 in Corbettmaths. In M5 we were given instructions and words, so translate shape A, 4 squares to the right, 3 squares downwards, and so on. In M6 we're given a translation vector, and a vector looks something like this, where we're going to have a number on the top and a number beneath and some brackets around it. The number on the top will tell you how to move the shape horizontally, and it'll tell you how many squares to the right to move it. So for instance, if it's an 8, you'll move it 8 squares to the right. If it's a 5, it'll be 5 squares to the right. If it's a 0, you won't move it any squares to the right, it'll stay where it is horizontally. If it's a negative, so for instance if it was -3, you would move it 3 squares to the left. If it was -9, it'd be 9 squares to the left. So the top number tells you how to move the shape horizontally, and if it's positive it'll be to the right, if it's negative it's to the left. The number beneath that will tell you how to move the shape vertically. So if it's positive, here it's a 1, so that's going to mean move the shape 1 square upwards. If it's a 4, you move it 4 squares upwards, and if it's negative you move it downwards. So if it's -3, you'd move it 3 squares downwards. So here we've got a typical question, and we've got a little shape. It's a little T shape, and the shape's called C, and we've been asked to translate shape C by, and we've got -1, 5. That will mean 1 square to the left, so 1 left, because it's negative, it's going to go to the left, so 1 left, and then we've got a 5, that's going to mean 5 up. So we're going to move the shape 1 square left and 5 squares up. So what I'm going to do is start with one corner, and I'm going to move it 1 square left and then 5 squares up. So 1, 2, 3, 4, 5. So the top left corner will move there. Now looking at the top right corner, we're going to move it 1 square left and then 5 squares up. 1, 2, 3, 4, 5. Next, I'm going to do the bottom right corner, so 1 square left and 5 squares up. 1, 2, 3, 4, 5. So it's going to move there. The bottom left corner, 1 square left and 5 up. 1, 2, 3, 4, 5. So as you can see, we've translated shape C. -1 means 1 to the left, and 5, which is 5 up. And let's just get a ruler and pencil and join them up. And that's it. So if we had a translation vector like this, 3 minus 2, that would mean translate the shape 3 squares right and 2 squares downwards. If we had this one, -4, 0, it would mean translate the shape 4 squares left and none up and down. It would just mean move the shape 4 squares left, and so on. So this is called a translation vector, and in M6 you need to be able to know what it means and how to translate shapes using them, and maybe even how to describe a translation by using the vector as well. Okay, our next topic. So next topic is rotations, and in M6 we're going to be doing rotations where it's about a point. The center of rotation won't necessarily be the origin. So here we've got rotate shape A 90 degrees anti-clockwise about the point 2 minus 1. So in this question you can see it's not the origin anymore, it's 2 minus 1, so let's mark on the point 2 minus 1. So this is going to be our center of rotation, and we're going to rotate shape A 90 degrees anti-clockwise, so going this way, anti-clockwise, about that point. So get your tracing paper and put it on top of the center of rotation and the shape like so, and make sure your tracing paper is straight, so it's straight and it's not diagonal like something like that. So make sure, in this case I put it landscape, so going that way. And what we're going to do is we're going to draw over the center of rotation and we're going to draw over the shape A. So we've drawn over the center of rotation and we've drawn over shape A. So now what we're going to do is we're going to put our pencil on the center of rotation and we're going to rotate the tracing paper 90 degrees anti-clockwise. So when we do that, we turn it, and it's important to keep the center of rotation on that point. We're turning it like so, until we've rotated the tracing paper 90 degrees anti-clockwise. And we can now see the position of where A would go after we rotated it 90 degrees anti-clockwise about 2, -1. So now what I would do is I would just draw over this rectangle a couple of times, just to make sure that whenever I move my tracing paper, that there's a sort of a light impression on the paper. So it would look something like this. And that's it. So we've rotated A 90 degrees anti-clockwise about the point 2, -1. Okay, so let's have a look at our next topic. So our next topic is reflections, and in M6 we have to reflect shapes in vertical or horizontal lines where it's not necessarily the y-axis or the x-axis. So in M5 it was always the y-axis or the x-axis. In M6 we're going to have to draw over lines. So we've been asked to reflect this shape C, in the line x equals -1. So this line x equals -1 is going to be a line going straight through -1 on the x-axis. So if we go to the x-axis and go to -1 here, it's going to be a vertical line going straight through that -1. So that's where our mirror line is going to be. And all of the points on the line x equals -1, well, they have an x-coordinate of -1. This is -1,6, this is -1,5, -1,4, -1,0. So all of those points have an x-coordinate of -1. So an x equals line will be a vertical line going through whatever number that is on the x-axis. Now we have to reflect the shape C in that mirror line. So let's start off with this corner. So this corner is 1, 2 to the mirror line. So we need to go in over 2, 1, 2. So it's going to move to here. The bottom right hand corner of C, well, it's 1, 2, 3, 4 to the mirror line. So we're going to go 1, 2, 3, 4 to here. And the top of triangle C is here. So it's 1, 2, 3, 4 to the mirror line. So we need to go another 4, 1, 2, 3, 4. So it's going to be there. Now we get a ruler and pencil and we just join up that shape. And we have reflected C in the line x equals -1. Next, we're going to reflect the shape C in the line y equals 1. So let's just rub out what we've done. So we've got our shape C again, and we're going to reflect it this time in the line y equals 1. So what we're going to do is we're going to go to the y-axis and the point 1. So the y-axis and the point 1, and we're going to draw a horizontal line going through that point. So going through 1 on the y-axis. And all of these points have a y-coordinate of 1. So in other words, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, and so on. So if you've got a y equals and a number, it'll be a horizontal line passing through that number on the y-axis. And we have to reflect this shape, this triangle, in that mirror line. So let's start with this bottom left-hand corner of C. It's 1 above the mirror line, so let's reflect it to 1 below. This point is 1 above the mirror line, so we're going to go another 1 downwards, so there. And finally, this point, to get to the mirror line, we go 1, 2, 3 down, so let's go another 3, 1, 2, 3 to there. And let's join up those points. And that's it. So reflections in M6, they're very similar to reflections in M5, except for you have to find where the mirror line is first of all. If the line is in x equals and a number, it'll be a vertical line and it'll pass through whatever number that is on the x-axis. So if, for instance, we had x equals 5, there'd be a mirror line going vertically through 5 on the x-axis, like so. And if the line was, for instance, y equals 1, what you'd have is then a horizontal line passing through 1 on the y-axis, and that's where the mirror line would be. Okay, let's have a look at our next topic. So next topic is enlargements, and in M6 the enlargement is going to be in a position where it's not necessarily the origin as the centre of enlargement. So here we've got shape A on this grid, and we're told the shape B is an enlargement of shape A, scale factor 3, with the centre of enlargement 3, 2. So let's plot the point 3, 2 to begin with. So 3 across 2 up, that's going to be our centre of enlargement. Now, whenever we enlarge shape A from the centre of enlargement 3, 2 by scale factor 3, that means each of these points are going to become 3 times further away from the centre of enlargement. So if we start off with this point here, that is 1 to the left from our centre of enlargement. When we enlarge by scale factor 3, instead of being 1 to the left, it's going to be 3 times further, which is 3 to the left. So let's go back to the centre of enlargement and go 3 squares to the left. 1, 2, 3. So it's going to move to there. Okay, our next point, this top left-hand corner. So that top left-hand corner is 2 squares left from the centre of enlargement. So we're going to multiply that by 3. It's going to be 6 to the left. So going back to the beginning, 1, 2, 3, 4, 5, 6. So that'll be there. Okay, this bottom left-hand corner, it is 2 to the left and 2 down. Well, if we multiply by 3, it's going to be 6 to the left and 6 down. So 1, 2, 3, 4, 5, 6 to the left and 6 down. 1, 2, 3, 4, 5, 6. So that's there. The bottom right hand corner, that's 2 down from the centre of enlargement. So when we multiply by 3, it's going to be 6 down. So 1, 2, 3, 4, 5, 6. Okay, our next point, this point, it's 1 down from our centre of enlargement. So let's multiply that by 3. So that's 3 down. 1, 2, 3. And finally, this point here, that's 1 left and 1 down. So when we multiply that by 3, it's going to be 3 left, 1, 2, 3, and 3 down, 1, 2, 3. And as you can see now, we've got all our points for our enlarged shape. And when we join them up, we get this shape, and that is shape B. So let's label it shape B. That's it. So we've enlarged shape A by scale factor 3. Okay, next question. Well, the next question says, James says the perimeter of B is 3 times larger than the perimeter of A. Is he correct? Well, whenever we enlarge a shape, all the sides become 3 times larger. So that means the perimeter should become 3 times larger. Let's check and see. So the perimeter of A is 8. Let's check the perimeter of B. So that's 3 times larger. It should be 24. Let's check and see.
We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I'm just counting all these lines, 23 and 24.
So the perimeter of B is 24. So he is correct, yes. Okay, let's have a look at our next question. So our next question is quite an important one, and it says James says the area of B is 3 times larger than the area of A, probably because we've enlarged by a scale factor 3. Is he correct? Now, James won't be correct, and let me just explain why. The area of A is 1, 2, 3 squared, and the area of B is 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 3 times bigger. Well, it's actually much bigger than that.
10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 and 27.
So the area of A is 3 and the area of B is 27. As you can see, it's much bigger than 3 times larger. So whenever you enlarge a shape by scale factor 2, the area won't be just double the size. It's actually going to be 4 times bigger. If you enlarge by scale factor 3, it won't be just 3 times bigger, it's actually 9 times bigger. Whatever the scale factor is, the area will actually be squared that. So if we enlarge by scale factor 4, the area would actually be 16 times bigger. And the reason is because we're enlarging all the sides by that scale factor, so the area will actually be much bigger than just that scale factor. It'll be that scale factor squared. So is he correct? No. Okay, our next topic. Our next topic is constructions. Okay, let's have a look at our next topic. And our next topic is constructions, and they are video 78, 72 and 79 on Corbettmaths. And if you want to watch me do these constructions where I'm filming myself actually doing the constructions, those videos will actually show that. But here what I'm going to do is show you step by step on how I would do the constructions. So first of all, our first question says, construct the perpendicular bisector of AB. So first of all, what is a perpendicular bisector? So perpendicular means 90 degrees and bisector means to cut in half. So if we were asked to construct the perpendicular bisector of AB, it would be a straight line that cuts AB in half going through the middle at 90 degrees. So it would be cutting this line AB in half at 90 degrees. And to do that, by using a pair of compasses and a pencil, what you would do is, first of all, you would get your pair of compasses and you would put the point of the compass on A, and you would put the pencil on the compass and you would set it over halfway of the line. So I've just chosen this point. It's definitely over halfway off the line, and I've drawn this semicircle starting at A, and I've drawn the semicircle around, so keeping the point here and making sure I draw a nice semicircle going around. Now lifting up your compass and your pencil and making sure it doesn't change size, put the point of the compass on B, and then what we're going to do is we're going to do the same thing. So we're going to do another arc. We're going to put a point of the compass on B and we're going to do another arc, and making sure it's the same size as the arc we done at A. And then finally what we're going to do is get a ruler and pencil and draw a nice straight line through those, and this line will be our perpendicular bisector. So that line will cross our line AB at 90 degrees, so it's perpendicular, and it's a bisector because it cuts the line AB exactly in half. So if that line AB was 10 centimeters, you would have 5 centimeters to the left here and you'd have 5 centimeters to the right. So that's it. Okay, next we're going to construct the angle bisector. So here's an angle ABC, and we're going to cut this angle in half by using a compass, a pencil and a ruler. So the first thing we're going to do is we're going to put our point of our compass on B. So we're going to put the point of our compass here, and we're going to do an arc on the line AB here and an arc on the line BC here. And it's important that you keep the compass the same size for both of those arcs. So you put the point here and you just move it so you've got an arc there on the line AB and an arc here on the line BC. Okay, so next we're going to lift up our compass and we're going to put the point of the compass here. So we're going to put the point of the compass where the arc and the line AB meet, and we're now going to do an arc in this direction. So we're going to get our compass and we're going to do an arc in this direction, and it'll look something like this. So that's where the point of the compass is, and we do this arc looking like that. Now we're going to lift it up and we're now going to put the point of the compass here, and we're going to do another arc in that direction, and it would look something like this. And then finally what we're going to do is get a ruler and a pencil, and we're going to join up the center of the angle ABC to where those two arcs meet, and that will be our angle bisector. That line will cut this angle exactly in half. So if this was a 60-degree angle, you would now have 30 degrees above it and 30 degrees below. So that line is called the angle bisector. And that's a very important construction. So we've constructed the perpendicular bisector and we've now constructed the angle bisector. Okay, our next construction is to construct a line perpendicular to AB. So it's going to be a line that's at right angles to AB and that passes through the point C. So it's going to be a line that passes through C and is at right angles to AB. And we're going to do that again with our compass, our pencil and our ruler. So first of all, what we're going to do is get our compass, and we're going to put the point of the compass on C, and we're going to set it so that it's longer than the distance between C and the line, so it's a bit further than that. So it's not just going to reach the line, it's going to be a bit further, but it also needs to make sure that it reaches the line on two different places. So if I set it too large, so if I set it over here, it would cross somewhere over here, but it wouldn't actually meet the line. So I've set it about here, so it's a bit longer than the distance to the line, and we're going to do two arcs, one here to the left and one arc to the right. And again, it's very important that you keep your compass the same size the whole way through. Next, what we're going to do is, keeping the compass the same size, we're going to now lift it up and we're going to put it on the point here. Okay, so putting the compass here, what we're doing is an arc below the line, and it's going to be below C, so it's going to be an arc in this direction. And then we're going to lift it up and we're going to repeat it here. So we're going to put our point of our compass here, and we're going to do another arc below. And if you get your ruler and pencil and join up from C to where those two arcs meet at the bottom here, that line will be perpendicular to the line AB, and it will obviously pass through C. And that's it. So we've constructed the perpendicular to the line AB that passes through the point C. We're now going to construct a perpendicular to the line AB that passes through the point C, which is on the line. So in other words, we're going to make a perpendicular line using our ruler, our compass, and our pencil, and it's going to be a perpendicular line to AB, so it's going to be at right angles, and it's going to pass through the point C. So our first step is to put the point of the compass on C, and we're going to set the compass so that it's getting close to the distance between C and B. So I'm going to put it about this distance here, and we're going to do an arc on this side, and we're going to keep it the same size and do an arc on the other side. So it would look something like this. So we've put the point of the compass there, and we've done an arc on this side and on that side, and it's the same distance. Okay, so now what we're going to do is we're actually going to look at this line going from here to here, and we're now going to construct the perpendicular bisector of that, so using the same steps as before. So our first step is to put the point of the compass here and set the pencil so it's past C, and then we're going to do an arc above C and below C. And keeping the compass the same size, we're then going to swap over, and we're going to put the point of the compass here, and again keeping it the same size, we're going to do an arc above and below. And then finally, if we join up these 2 points there and there, that line will pass through C at 90 degrees. So that is a line that is perpendicular to AB and passing through C. And that's it. Our last construction that we're going to look at is constructing an equilateral triangle. And remember, an equilateral triangle, all the sides have the same length. So this is quite a nice one, that if you put your point of your compass here and you put your pencil of your compass on the end of the line, that'll be 5 centimeters. And then if you do an arc above, it would look something like that. So all of these points are 5 centimeters away from here. Now keeping the compass the same size and putting the point of the compass on this side and putting the pencil here, now doing the same thing. And then we'd end up with something that looks like this. And this point here would be 5 centimeters away from this end of the line, and would also be 5 centimeters away from this end of the line. So if we get a ruler and pencil and join them up like so, so there and there, that will be an equilateral triangle. So it'll be a triangle where the sides are 5 centimeters. So that's 5 centimeters, that's 5 centimeters, and that's 5 centimeters. And also the angles will be 60 degrees. So that'll be 60 degrees, that'll be 60 degrees, that'll be 60 degrees, and that's it. Okay, so they were our constructions. If you do want to watch full videos on them and me showing you how to do each one of them really clearly using a compass, a ruler, and a pencil, watch the videos above there. Okay, let's have a look at our next topic. So our next topic is Loci, and that's video 75, 76, and 77 on Corbettmaths. And our question says to draw the locus of all the possible points that are 2 centimeters away from the line below. So in other words, we've been given a rule and we've got to draw on all the possible positions that points can be that follow that rule. So we want to draw all the points that are 2 centimeters away from this line. So the points above the line would be quite straightforward. You could be 2 centimeters just above the end. You could be 2 centimeters above there. You could be 2 centimeters above here. And you could be anywhere that's 2 centimeters above the line, like so. Alternatively, it could be 2 centimeters below the line, so it could be 2 centimeters there, 2 centimeters there, and you get your ruler and pencil, you make sure all the points are 2 centimeters below the line. So it looks something like this, where you've got all the possible points above the line and all the possible points below the line. And then what you do is get your ruler and join and go through the points. They're all 2 centimeters above and below. Now obviously if you're using a ruler and pencil, they would all be in a nice straight line, so this point here wouldn't be there, it would be actually up there. Okay, and so these points above here and below here are all 2 centimeters away from the line. But what about the end of the line? So if we're at the end of the line here, we could have 2 centimeters to the right, so that would be there. And then we could be 2 centimeters here, or 2 centimeters here, or 2 centimeters here. And as you can see, we're forming this semicircle where they're all 2 centimeters away from the end of the line. So it looks something like this. And with a compass and a pencil, you'd put the point of your compass here and your pencil here, and you draw a nice semicircle going around like so, and that would join up perfectly. Excuse my freehand one, but that's just a little sketch there. And likewise, if we're at the end of this line here, we could have 2 centimeters here, and if we measure the points that are all 2 centimeters away from the end of the line, again it would be another semicircle. And all of these points would be 2 centimeters away from this end of the line. So what we would do is again get the point of our compass and put it there, and then put the pencil 2 centimeters away, and then draw a nice semicircle going around through those points. So that's it. Okay, let's have a look at our next question. So this time we've got a diagram, and we've got the points A and B, and we've got a scale that 1 centimeter is 1 mile, and we've got land and we've got sea. And the question says a boat is within 8 miles of A, so it's within 8 miles of A, and it's within 5 miles of B. Shade the possible positions of the boat. And one thing I should have said in this question is the boat's at sea. So it's not on land, it's at sea. So we know that it's within 8 miles of A. And we know that 1 centimeter is 1 mile. So what I would do is I would measure 8 centimeters, and I would set my compass so that it is 8 centimeters. So I put the point of the compass on A, and I would put the point, my pencil, so it's 8 centimeters away. So I put my pencil where the sea and the land meet, and I would draw a circle. And this circle has got a radius of 8 centimeters, and it would look something like this. It's a freehand sketch, sorry. It's got a radius of 8 centimeters, and it's a circle that looks something like that. Okay, next, we're now told that the boat is within 5 miles of B. So within 5 miles of B, and that's 5 centimeters. We'd get our compass, we'd measure it, so the distance between the point and the pencil is 5 centimeters, and we'd put the point here, and it would be over here somewhere. So we'd put the pencil where the sea and the land meet, and we'd draw another circle. And this circle's a bit smaller, it's only got a radius of 5 centimeters this time, and it would look something like that. And again, sorry, excuse my diagram. So this circle has got a radius of 5 centimeters, and this circle has a radius of 8 centimeters. And we were told that the boat's within 8 miles of sea, so in other words, it's in here somewhere, but it's also within this circle as well. So that means the possible positions of the boat would be in this region here. And that's it. If you want more practice on loci, videos 75, 76 and 77 will go through more examples. Also, there's some fantastic practice questions that you can do on Corbettmaths. So if you go to Corbettmaths and go down to worksheets and click on it and go down to those video numbers, beside that you'll see practice questions, and they'll be ideal to practice as well. Okay, our next topic is congruence, and you need to know what the word congruent means. Congruent. And congruent means exactly the same shape and size. So on this grid, we've got some shapes that are congruent to each other. So shape A is congruent to I. So A and I are congruent to each other. We've got some more shapes that are congruent. We've got B and D. B and D are congruent, so B and D. F and H would be congruent because they're right angle triangles, and they've both got a height of 2 and they've both got a base of 2, so F and H are congruent as well. So congruent means exactly the same shape and size. So it means all the sides are the same length, but also all the angles are the same size as well. Okay, let's have a look at our next topic. So our next topic is laws of indices, and that's video 174 in Corbettmaths. And now what we're going to do is we're going to look at laws of indices whenever we're using algebra as opposed to using numbers. But the same rules apply. So for instance, if we had m to the power of 3 multiplied by m to the power of 4, we just add the powers, so it'd be m to the power of 7. If we had m to the power of 8 divided by m to the power of 2, we take away the powers if we're dividing, so that'd be m to the power of 6. And then finally, if we had a power to a power, so we've got a power and then a bracket and then a power outside, we'd multiply the powers together. So if we had m cubed squared, we then have m to the power of 6 by multiplying the powers together. Okay, and this is the Corbettmaths revision card on laws of indices, so this might be quite useful if you've got the revision cards as well. So let's have a look at our examples. We've got y to the power of 8 multiplied by y to the power of 3. So we've got y times y times y times y 8 times, and then we're multiplying that by another y times y times y. So that altogether there'll be 11 y's multiplied together, so that'll be y to the power of 11. In other words, adding the powers together, 8 plus 3 is 11, so it'll be y to the power of 11. Next, we've got y to the power of 15 divided by y to the power of 5. Well, if we're dividing and we've got the same base, so they've both got a base of y, we just take away the powers. So we've got 15, take away 5 is 10, so it'll be y to the power of 10. And finally, if we had y to the power of 6 squared, we've got a power of a power, so we multiply the powers together, 6 times 2 is 12. So it'll be y to the power of 12. Or another way to look at this one is we've got y to the power of 6 multiplied by itself, so we could then add the powers and that would give us 12 as well. That's it. So that's the laws of indices. And in M6 we're looking at the laws of indices whenever we're looking at algebra. Okay, our next topic. Okay, so let's have a look at our next topic. So our next topic is trial and improvement. That's video 116 on Corbettmaths. And we've been asked to solve x cubed plus 7x equals 30 to one decimal place. So in other words, what's the value of x to one decimal place? Is it 5.8 or 7.2 or 2.4? What's the value of x to one decimal place? So what we're going to do is we're going to start off by choosing a value of x. Let's choose 2 to begin with. And what we're going to do is we're going to work out what 2 cubed plus 7 times 2 is. So we're going to substitute 2 in for the value of x. So we're going to do 2 cubed plus 7 times 2. So getting our calculator and doing 2 cubed plus 7 times 2 gives us 2 cubed plus 7 times 2 is equal to 22. So that's too low. We wanted 30, so 22 is too low. Next, well, we've tried 2, let's try 3. So we're going to do 3 cubed plus 7 times 3. So on our calculator, we'll type in 3 cubed plus 7 times 3. And that gives us an answer of 48. But we wanted 30, so that's too high. Now, we've got 2's too low and 3's too high. So we know our answer is going to be somewhere in between 2 and 3. So let's try 2.5 next. So if we try 2.5 cubed plus 7 times 2.5, we get that's equal to 33.125, which is too high. We wanted 30, we've got 33.125, so that's too high. Okay, so we want something a bit lower. Let's try 2.4. So 2.4 cubed plus 7 times 2.4. That gives us an answer of 30.624. Well, again, we want 30. That's above it, so that's too high. So let's try something a bit lower. Let's try 2.3. So if we try 2.3, we're going to do 2.3 cubed plus 7 times 2.3. So 2.3 cubed. So make sure you know where the cubed is on your calculator. So 2.3 cubed plus 7 times 2.3. And that gives me 28.267. So we wanted 30, so that's too low. Now we want to find our answer to one decimal place. So our answer will either be 2.3 or 2.4 because we know that 2.3 is too low and 2.4 is too high. So we know one of these two numbers is going to be our answer. We just need to find out which one's closest to our answer. Is 2.4 closer or is 2.3 closer? So to do that, what we're going to do is we're going to do a thing called the checker, which is 2.35. So in other words, I'm just going to do a little sketch here, and I like doing these sketches for trial improvement questions. We know that 2.3 is too low, and we know that 2.4 is too high. So we know our answer is going to be somewhere in between these. So if we do 2.35, we'll be able to find out, is our answer on this side or is our answer on this side? So let's try 2.35. So if we do 2.35 cubed plus 7 times 2.35, we get an answer of 29.427875. But we wanted 30, so that's too low. So we know that 2.35 is too low. So if you look at this number line between 2.3 and 2.4, well, we know 2.3 is too low, we know 2.35 is too low, we know 2.4 is too high. That must mean our answer is somewhere in between 2.35 and 2.4. It's in here somewhere. So that means our answer is closer to 2.4 than it is to 2.3. So our answer would be 2.4. So our answer is 2.4. And it's very important whenever you do this trial improvement questions to do that checker in the middle to just confirm which one's closest and to get that right answer. And that's it. Okay, let's have a look at our next topic. Okay, let's have a look at our next topic. So our next topic is solving inequalities, and that's video 178 in Corbettmaths. So our first question says solve 5x is bigger than 30. Now whenever I'm solving inequalities, I use a similar approach to I would use for solving equations. So here we've got 5x is bigger than 30. Now we don't want 5x, we want just x. So we want to get rid of this multiplied by 5. So to get rid of this 5, we're going to do the opposite, which is divide by 5. So we're going to divide both sides by 5. So if we divide both sides by 5, well, 5x divided by 5 would be 1x, or x, and that would be bigger than, and if we done 30 divided by 5, that would be 6. So the answer would be x is bigger than 6. Okay, this time we've been asked to solve 3x plus 4 is smaller than or equal to 31. So if this was an equation, the first thing I would want to do is get rid of this plus 4. So let's take away 4 and take away 4 from both sides of the inequality. So we've got 3x plus 4. We're taking away 4, so that leaves us with 3x. And then we've got our less than or equal to sign. And then we're taking away 4. 31 take away 4 is 27. So we've got 3x is smaller than or equal to 27. Now we don't want 3 times x, we just want x, so let's divide both sides by 3. So dividing by 3 and dividing by 3 would give us, well, on our left hand side, we're dividing by 3 to get rid of this times by 3, so we're just left with x. And then we've got smaller than or equal to, and then if we do 27 divided by 3, well, 27 divided by 3 is 9. So if we've been given the question 3x plus 4 is smaller than or equal to 31, well, we know that x will have to be smaller than or equal to 9. That's it. Okay, let's have a look at our next question. So this time we've got an inequality with letters on both sides. So remember, whenever we're solving equations with letters on both sides, we want to get rid of the lowest number of x's. So here we've got 8x plus 1 is smaller than 10x subtract 6. So with this inequality, I'm going to get rid of the lowest number of x's, which is our 8x. So let's take away 8x from both sides of this inequality. So when we do that, we had 8x plus 1, we took away the 8x, so we're just going to be left with plus 1 or 1. And that's smaller than, well, we have 10x take away 6, and we're taking away 8x, so that's going to leave us with 2x. So we've got 2x take away 6. Okay, now like an equation, I would want to get rid of this take away 6, so let's add 6 to both sides of this inequality. So 1 plus 6 is 7, so we've got 7 is less than 2x, and we added 6 to get rid of the minus 6, so we're just left with 2x. And finally, we want the x on its own, so we want to get rid of this multiply by 2, so let's divide by 2 and divide by 2. And whenever we divide 7 by 2, we get 3.5, so that's 3.5 is less than x, and that's it. So we've got 3.5 is less than x. Now we might want to write this the other way around, so we've got the x at the front. So if we write this the other way around, just be aware whenever we write it the other way around, we've got x. Now we've got 3.5 is less than x, or if we read it the other way around, we've got x is bigger than 3.5. So we need to flip that inequality sign round whenever we're writing it the other way around, because x is bigger than 3.5, and that's it. So whenever you're solving inequalities, it's similar to solving equations, but you just need to be aware of whenever you are wanting to flip it around. So in other words, whenever you want the x at the front rather than the number at the front, whenever you flip it around, that you need to be aware of that inequality sign. Okay, let's have a look at our next example. So our next question says, solve 9 minus x is bigger than 11. Now the first thing I notice whenever I look at this inequality is we've got a minus x. What I'm actually going to do is I'm going to add x to both sides of this inequality. So when I add x and add x, that would give me, well, on the left hand side I had 9 take away x, and then I added x. Well, I added x to get rid of the minus x, so that would just leave me with 9 on the left hand side. Then we've got our bigger than sign, our greater than sign, and then we've got 11 plus x, so it will just be 11 plus x, like so. Next, well, we want x on its own, we don't want this 11 here, so let's take away 11 from both sides of the inequality sign. So let's take away 11 and take away 11. Well, 9 take away 11 is minus 2, so we're going to have minus 2 on the left hand side. And on the right hand side, we had 11 plus x. We took away 11. Well, 11 take away 11 is 0, so we would just be left with the plus x, or the x. So we've got here, negative 2 is greater than x. If we wanted to write it the other way around, we can turn it around, but we have to turn that inequality sign around as well. So we'd write x, and instead of writing a bigger than, we'd write a smaller than, and then we've got negative 2. So that means that our answer is x is smaller than negative 2, and that's the same as negative 2 is bigger than x. So that's our answer. Okay, let's have a look at our next topic. So our next topic is inequalities, but this time we're dealing with number lines. So it's representing inequalities on a number line, and it's also looking at how to solve inequalities and then represent the answer on a number line. And this would be video 177 on Corbettmaths. So let's look at how we'd represent some inequalities on a number line. So here's a number line, and our first inequality is x is greater than negative 1. So x is bigger than negative 1. So first of all, what we do is we go to negative 1, and because x is greater than negative 1, it can't actually be negative 1. So what we do is we put a hollow circle at negative 1. So we put a hollow circle at negative 1, and because x can be bigger than negative 1, what we do is we put an arrow to the right, like so, and we just do an arrow, and that tells us that x can be any value that is bigger than negative 1. And because the circle's hollow, it shows us that it can't actually be negative 1, so it's any number greater than negative 1. So if we wanted to show that x was greater than negative 1 on a number line, we do a hollow circle at negative 1, and then an arrow pointing to the right, the numbers that are bigger than negative 1. If our inequality was x is greater than 2, we would do a hollow circle at 2, and then an arrow to the right, and that's it. It just says x is bigger than 2. Okay, let's have a look at our next inequality. Okay, this time our inequality says x is greater than or equal to 2. Now this time we've got x is greater than or equal to 2. So that means it can actually be 2 and any number that's bigger than 2. So instead of doing a hollow circle, what we do is we actually do a circle and colour it in. So a shaded in circle, and then an arrow to the right, like so. And what that means is that x can be 2 or any number bigger than 2. If our inequality was x is greater than or equal to 0, we would do a shaded in circle at 0. And then we would do an arrow to the right, and that would mean that x is bigger than or equal to 0. And that's it. Let's have a look at our next inequality. So our next inequality is x is smaller than negative 2. So this time what we're going to do is, because it's smaller than, so it's not equal to, we do a hollow circle, and the arrow points to the left because it's smaller than negative 2. And that's it. So if we had an inequality such as x is smaller than 4, what we would do is we would do a hollow circle of 4, an arrow to all the numbers that are smaller than 4, and an arrow just says that it goes on forever. Okay, and our next inequality. So our next inequality is x is smaller than or equal to 3. So because it's smaller than or equal to, instead of doing a hollow circle, we do a shaded in circle at 3. And we do an arrow to the left, like so. And that's it. So that's how we represent inequalities where we've just got x is bigger than a number, or bigger than or equal to a number, or less than a number, or less than or equal to a number. And if we had an inequality such as this, where x is bigger than 1, but less than or equal to 3, and I wanted to represent an inequality like that on the number line, because we know that x is bigger than 1, but we know it's bigger than 1, so it can't be equal to 1, so we do a hollow circle at 1, and because x is smaller than or equal to 3, because it can be 3, we do a shaded in circle at 3, and because x can take the values in between those numbers, we join them up like so. So if we wanted to represent an inequality such as x is bigger than 1 but less than or equal to 3, we would do a hollow circle at 1, a shaded in circle at 3, and that represents that inequality on a number line. Okay, let's look at our next question. So this time we've been asked to solve 5x minus 6 is less than 4, and we've been asked to show our answer on a number line. So let's first of all start off by solving this inequality. So we have 5x minus 6 is less than 4. So like an equation, we want to solve this and get x on its own. So let's add 6 to both sides. So add 6 and add 6. So on the left hand side, we had minus 6. We added 6 to get rid of it. So we're just going to be left with 5x. And on the right hand side of our inequality, so we have our less than symbol. And then we've got 4 plus 6, and 4 plus 6 is 10. So we've got 5x is less than 10. We don't want 5x, we actually just want x on its own. So let's divide by 5 to get rid of this multiply by 5. So dividing by 5 and dividing by 5 gives us x is less than, and 10 divided by 5 is 2. So solving our inequality, our answer would be x is less than 2. And if we wanted to show that on a number line, because this is less than 2, we do a hollow circle. And then because it's less than 2, we do an arrow to the left for all the numbers that are less than 2. And that's it. Okay, let's have a look at our next topic. Okay, our next topic is changing the subject. So here we've got a formula. We've got t is equal to AW take away c. And at the minute, the capital T is the subject because it's on its own. The t is on its own there, so t is the subject. But we want to make w the subject. So what that means is we want to get the w on its own. So we don't want this take away c, and we don't want this to multiply by a. So what we're going to do is, like an equation, we're going to get rid of this take away c and multiply by a. So let's write out our formula. We've got t equals AW take away c. Now we want to get the w on its own, so let's get rid of this take away c to begin with. So if I wanted to get rid of take away c, I'm going to add c to both sides. So add c and add c. Well, t plus c was just t plus c, we just read it out. And then on the right hand side of our formula, well, we had AW minus c, we added c to get rid of the minus c because minus c plus c is 0, so we would just be left with AW. Now we want to make w the subject, which means we want to have the w there on its own. This is a times w. We're multiplying the w by a. We don't want to multiply the w by a, so let's divide both sides by a. So let's divide by a and divide by a. On our right hand side, we had AW. We divided by a to get rid of it, so we'd just be left with w. On the left hand side of this formula, we had t plus c, and we're dividing that by a. So what we're going to do is write t plus c. Now remember in algebra, we don't write the divide by sign, and we do over a. And that means we've got t plus c divided by a. And that's it. So we've got w on its own. So w is the subject. So our answer would be w equals t plus c over a. And that's it. And changing the subject is video 7 on Corbettmaths. So if you want to watch more examples of changing the subject, starting off with some simple questions and building up to questions like this, video 7 will be really, really useful. And also remember, there's the practice questions and the textbook exercise there as well. If you do have the revision cards, changing the subject is one of the revision cards. And as you can see here, we've got a typical change in the subject question where it says make w the subject, and it goes through step by step explaining how you would make w the subject with that formula. So changing the subject is a very important topic. It's video 7 on Corbettmaths, and if you do have the revision cards, that revision card will be really useful for it. Okay, let's have a look at our next topic. So our next topic is the nth term. So whenever we've got a sequence, there's often a rule or an nth term for it, which means that we can find out any term in the sequence by substituting which value we're looking for. So here we've got our sequence, 3, 8, 13, 18, and so on. As you can see, we're going up in fives because we're adding 5, adding 5, adding 5, and so on. And we've been asked to find the nth term of this sequence, in other words, the rule for the sequence. So if we want to find the nth term, our first step is to consider the sequence and see what it's going up in or going down by. And this, as this sequence has gone up in fives, we're adding 5, adding 5, adding 5. What we're going to do is we're going to write the 5 times tables beneath the sequence. So the 5 times tables are 5, 10 are the multiples of 5, 5, 10, 15, 20, and so on. And because we're multiplying the numbers by 5, we're doing 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and so on. We're going to write 5n because that means 5 multiplied by n, because 5 times 1, 5 times 2, 5 times 3, and so on. So if the sequence is gone up in 5s, we write the 5 times table, so the multiples of 5 beneath it, and we write 5n in front. Now our sequence is not 5, 10, 15, 20. Our sequence is actually 3, 8, 13, and 18. And to get from 5 to 3, we take away 2. To get from 10 to 8, we take away 2. To get from 15 to 13, we take away 2. To get from 20 to 18, we take away 2. So if we took away 2 from all of these numbers, we would get our sequence. So that means if we had 5n minus 2, that would be 3, 8, 13, and 18. So that means our nth term is 5n minus 2. 5n minus 2. And let's just check it. Well, the first term in our sequence, well, if we do 5 times 1 is 5, take away 2 is 3. Great. The second term in our sequence is 8. Well, if we do 5 times 2, that's 10. Take away 2 is 8. Fantastic. Our third term, 5 times 3, 15. Take away 2 is 13, and so on. Let's work out another one. So if we had the sequence 7, 9, 11, 13, and so on. As this sequence is getting bigger by 2 each time, we write the multiples of 2 beneath the sequence. So that's 2, 4, 6, 8, and so on. And that's 2n. Our sequence, though, isn't 2, 4, 6, 8. Our sequence is 7, 9, 11, and 13. So to get from the multiples of 2 to our sequence, we'd have to add 5, add 5, add 5, and add 5. So that means our nth term would be 2n plus 5. So that means the nth term of this sequence would be 2n plus 5. And let's just check it. 2 times 1 is 2, plus 5 is 7. 2 times 2 is 4, plus 5 is 9. Great. 2 times 3 is 6, plus 5 is 11, and so on. So to find the nth term of a sequence, you consider what the sequences are going up or down by. You write their multiples beneath it, and then you figure out what you would need to do to those multiples to get to the sequence. Now, because I said down by, let's just have a look at an example where a sequence is going down instead of up. So let's have a look at one of those now. So if we had the sequence 15, 12, 9, 6, and so on, and if we look at our sequence, we can see we're going down by 3 each time. We're taking away 3, taking away 3, taking away 3, and so on. So that means that what we're going to do is we're going to write down the negative 3 times tables. So that's going to be minus 3, minus 6, minus 9, minus 12, and so on. So that would be minus 3n, because it's minus 3 times 1, minus 3 times 2, and so on. But our sequence is not minus 3n. It's not minus 3, minus 6, minus 9, minus 12. Our sequence was 15, 12, 9, 6. To get from minus 3 to 15, we would have to add 18. To get from minus 6 to 12, we would have to add 18. To get from minus 9 to 9, we'd have to add 18, and so on. So that means our nth term for our sequence would be minus 3n plus 18. And let's just check it. Our first term is 15. Minus 3 times 1 is minus 3, plus 18 is 15, and so on. So that is our nth term for our sequence that is going down. Now the nth term is really useful, because what we can actually do is we can use the nth term to work out terms in the sequence. If we had this sequence 3, 8, 13, 18, and someone asked me to find the 100th term in the sequence, rather than carrying on the sequence for 100 terms, I can use this nth term. So I can do, if I want the 100th term, I can do 5 times 100, which is 500, take away 2, which would be 498. So the 100th term in this sequence, without having to list them all down, would be 498. And that's great. So it saves us a lot of time and effort. Another reason why the nth term is quite useful is we can use it to work out if a term's in the sequence or not. So for instance, if somebody came along to me and said, is 200 in this sequence? Well, first of all, I can tell it's not, because our sequence goes 3, 8, 13, 18, and so on. And as you can see, the numbers end in a 3 or an 8, a 3 or an 8. So because 200 ends in a 0, it's not going to be in the sequence. But we can actually use the nth term to show that. We can actually write 5n minus 2, the nth term, and write equals 200. So that's an equation. And if we solve this equation and we get a whole number, so we get n equals a whole number, it would mean that 200 is in the sequence, and whatever whole number that is tells us which term in the sequence it is. But if whenever we solve this equation we get a decimal number, it would mean that the number 200 wouldn't be in the sequence. So let's solve our equation and see what happens. So if we had 5n minus 2 equals 200, we would add 2 and add 2. Well, we add 2 to get rid of the minus 2, so we're left with 5n, and on the right hand side we've got 200, add 2 is 202. Now we've got 5n, we don't want 5n, so let's divide by 5 and divide by 5. So that would give us 5n divided by 5 is n, and 202 divided by 5 would be 40.4. And as that's not a whole number, that means that 200 is not in the sequence. And because it's 40.4, it means it's not the 40th term and it's not the 41st term in the sequence. So that means that 200 is not a term in the sequence. Okay, let's have a look at our next topic, and our next topic is solving simultaneous equations by using graphical approaches. In other words, drawing the graphs and finding out where the graphs meet and using that to find the answer to simultaneous equations. So here we've got a pair of simultaneous equations, so that's two equations at the same time. We've got y equals 3 minus x and y equals 2x minus 3. So to solve this, what we're going to do is we're going to draw suitable lines. In other words, we're going to draw the graph for y equals 3 minus x, and we're going to draw the graph for y equals 2x minus 3, and where those two straight lines meet will be our answer. So let's first of all draw the graph for y equals 3 minus x. So to draw this graph, I'm going to draw an xy table. So it's x and y, and I'm going to do a little table like so. And if you need a recap on this, if you go to Corbettmaths.com and you go to linear graphs, there'll be a topic called drawing graphs using xy tables. And what I'm going to do is I'm going to choose some values for x, so 0, 1, 2, 3, and I'm going to work out the values for y. So y equals 3 take away x. So if I take away x from 3, I can find the value for y. So if x is equal to 0, well, 3 take away 0 is 3, so that means that y is 3. 3 minus x, well, if x is 1, it would be 3 minus 1, that's 2. If x is equal to 2, well, 3 minus 2 is 1, so that would be 1. And if x was equal to 3, I'd have 3 minus 3, which is 0. So the points in this graph will be 0, 3, so 0, 3. There'll be 1, 2, so 1 across 2 up. There'll be 2, 1, so 2 across 1 up. And there'll be 3 zeros, so 3 across and 0 up, like so. And if I get my ruler and pencil, I can draw a nice straight line through those points, and it would look something like this. And that's it. That's the graph for y equals 3 minus x. Now, in a typical question, I'd imagine what they would do is draw one of these two lines for you, and you just have to draw the other one and then find out where they meet. Okay, let's have a look at our next one. So our next graph is y equals 2x minus 3. So we'll do an xy table, x and y, and we'll choose some points. And again, I just tend to use 0, 1, 2, 3. And I choose a few of them, or in this case I choose 4 of them, just so whenever I plot them I can see that all 4 of them are in a nice straight line. If they're not in a straight line, then I know I've done something wrong. So what I'm going to do is to find y, we do 2 times x and we take away 3. So we're going to times all these numbers by 2 and then take away 3. So let's start off with 0. 2 times 0 is 0. Take away 3 would be minus 3. Then we've got 1. Well, 2 times 1 is 2. Take away 3 would be minus 1. Now we've got 2. 2 times 2 is 4. Take away 3 is 1. And finally we've got 3. 2 times 3 is 6. Take away 3 is 3. So we've got our coordinates 0, 3, 1 minus 1, 2, 1, and 3, 3. So let's plot them. 0 minus 3, 1 minus 1, 2, 1, and 3, 3. And get our ruler and pencil, we'll draw a nice straight line through those points. And as you can see here, the two straight lines meet at the point 2, 1. This is the point of intersection here, 2, 1, there. So that means they meet at the point 2, 1. Now when we're solving simultaneous equations, what we're trying to do is find the value for x and we're trying to find the value for y. So if we look at this point 2, 1, we're going 2 across, that means the x value is 2, because the coordinate's 2, 1. The first number is the answer for x and the second number is the answer for y. So x is equal to 2 and y is equal to 1. And let's just check that. 2 across 1 up, the x value is 2 and the y value is 1. And that's it. So if you want to solve simultaneous equations by using the graphs, what you do is you draw the graphs and you find out where they meet. And where they meet will be the answers, that'll be the solution. So you'll write down the x value being the x coordinate, the first number of the coordinate, and you write down the y value as the second number of the coordinate, and that's it. Okay, let's have a look at our next topic, and our next topic is quadratic graphs, and that's video 264 on Corbettmaths. So what we're going to do is we're going to draw this quadratic graph. And whenever we draw quadratic graphs, what you'll find is instead of being straight lines, they'll either be this U-shape or a parabola, like so, this U-shaped parabola, or they could be an N-shaped parabola, like so. And so whenever you draw a quadratic graph, it will either have this U-shape or this N-shape. And it depends on whether this x squared is positive or negative. So because this is a positive x squared, I can tell it's going to be a U-shape. If it was minus x squared, it would actually be an N-shape. Okay, so the question asks us to complete the table for y equals x squared plus x minus 4. So we've got this xy table and we've got lots of points. The reason we've got lots of points is it's not a straight line anymore, it's a curve. So we're going to need more points so we can draw a nice curve through them. And we've got our x values of minus 2, minus 1, 0, 1, 2, and 3. And what we're going to do is we're going to work out our y values. And to find our y values, we're going to square x, add x, and take away 4. So let's start off with 3. So we're going to do 3 squared plus 3 and then take away 4. So 3 squared is 9, plus 3 is then going to be 12, take away 4 is 8. So that means that would be 8. Now we've got 2, so we're going to do 2 squared plus 2 take away 4. So 2 squared is 4, plus 2 is equal to 6, take away 4 is 2, so that would be 2. Now we've got 1, so we're going to do 1 squared, plus 1, take away 4. So 1 squared is 1, plus 1, well, 1 plus 1 is 2, take away 4 is negative 2, so it's going to be negative 2. Now we've got 0, so we're going to do 0 squared, plus 0, take away 4. Well, 0 squared is 0, plus 0 is 0, take away 4 is minus 4, so that'd be minus 4. Next we've got negative 1, so we're going to do negative 1 squared plus negative 1 and then take away 4. So remember, when we square negative, we're doing a negative times a negative, which is a positive. So we're going to do negative 1 squared, so that's negative 1 times negative 1, which is 1. We're then going to add on negative 1 and then take away 4. So then we've got 1 plus negative 1. Well, if it was 1, add 1, it would be 2, but we're adding negative 1, which means it's going to go down 1. So 1 add negative 1 is actually 0. And then we're going to take away 4, which is minus 4. So that'll be minus 4. And then finally negative 2. So we're going to do negative 2 squared plus negative 2 and then take away 4. And when we do negative 2 squared, that's a negative times a negative, so that's negative 2 times negative 2, so that's a positive, so that's going to be 4. And then we're going to add negative 2, that means it's going to go down 2, so that'll be 2, and then take away 4 will be negative 2. So we've now found our coordinates. Now what we're going to do is we're going to plot them. So we're going to go 3 across and 8 up, so 3 across and 8 up. We've got 2 across and 2 up, so 2 across and 2 up. 1 across and 2 down, so 1 across and 2 down. 0 across and 4 down, so 0 minus 4. We've got negative 1 and negative 4, so negative 1, negative 4. And finally, negative 2 would be negative 2, and negative 2 would be there. So we've now got our points, and as you can see, they make a curve. So what we're going to do is we're going to draw a nice curve through them. So I'm going to do this on the computer, and it can actually be quite tricky on the computer, so please bear with me whenever I'm doing it. So it might not be absolutely fantastic, but I'll do the best I can. Hey, that's pretty good. So that's it. So we've drawn a quadratic graph and we've drawn a nice curve for our points. And that's it. So that's a quadratic graph, and that shape is called a parabola, and it's typically a U shape, or it can be an N shape as well. And often you'll be asked to find missing numbers in this table. Sometimes some of the numbers are worked out for you, so you have to work out a few of them, the missing ones, and then plot them and draw your nice curve through them. And that's how you would plot and draw a quadratic graph. And if you want more practice, video 264 in Corbettmaths will give you more practice on that. And remember, you've got that bumper pack of questions, so that M6 ultimate video practice question booklet, and if you go to that in the description below and click on it, there'll be questions there on the quadratic graphs, and it'll give you a chance to draw one yourself. Okay, so let's have a look at our next topic. So our next topic is solving quadratics graphically. And in M6 you might be asked to find out where your quadratic graph meets a horizontal line. So it could be something like this, where using your graph, estimate the values of x whenever y is equal to negative 3. So if we go back to our graph, we need to now draw the graph of y equals negative 3, because we're told to find the values of x whenever y is equal to negative 3. So if we draw that graph of y equals negative 3, that's going to be all the coordinates with a height of negative 3, such as 0, negative 3, 1, negative 3, 2, negative 3, 3, negative 3, and so on. The graph y equals negative 3 is a horizontal line that passes through 3 on the y-axis. So y equals a number graph will be a horizontal line, and it'll be horizontal going through whatever the number is. So if it was y equals negative 3, it'll be a horizontal line going through negative 3 on the y-axis, because all the coordinates on that line have a height of negative 3. If it was y equals 8, it would be a horizontal line going through 8, and so on. Okay, but in our question we were asked to find an estimate of the values of x whenever y is equal to negative 3. So if you have a look at our parabola and our straight line, our y equals negative 3, you can see they actually meet each other twice. They meet here and they meet here. And what we're actually going to do is we're going to go up to the x-axis, so just going up to here, there, and going up from this intersection point, this second intersection here, we're going to go up again to the x-axis there. And we're going to read off what those values would be, and they would be our two solutions. And it says estimate because remember we've drawn a curve and we've drawn it freehand, so it's not going to be perfect, this question. It's an estimate to our answers. So let's have a look and see what we've got. So let's start off with this one. We've got 0, we've got 1, and in the middle is 0.5. I think that's about 0.6. So I'm going to say x equals 0.6 would be one of our solutions. And this one over here, well, we've got 0, we've got negative 1, we've got negative 2. That's negative 1.5. I think that's about negative 1.6. So negative 1.6. So our two estimates would be x equals 0.6 or x equals negative 1.6. So there will be our two estimates. So x equals 0.6 or x equals negative 1.6. Just to also point out that the question could be written in a slightly different way. Rather than saying find estimates of the value of x whenever y is equal to negative 3, it could have had the equation of the graph that we drew in the first question, this x squared plus x minus 4, and it could have just written equals negative 3, and then what you do is you'd look at that value, you just draw the graph of y equals negative 3 like we did, so we just draw a horizontal line going through negative 3 and go up to the x-axis and find those values. Okay, let's have a look at our next topic. So now we're in the statistics and probability topics, the orange topics, and this is video 253 in Corbettmaths. And we're looking at listing outcomes. And the question says, two fair dice are rolled and the total score is found by adding their numbers. List all possible outcomes. So we're going to roll two dice and we're going to add the scores together and we're going to list all the possible outcomes. So we've got two different events. They're independent of each other. They're one dice being rolled and another dice being rolled. And the score is found by adding them together. So I'm thinking of the game Monopoly, and I'm thinking I'm rolling two dice and what are the scores we can get. So the lowest score we can get is going to be a 1 and a 1. Well, that's going to be, when we add them together, that would give us 2. We could have a 1 and a 2, that would be 3. A 2 and a 2, which would be 4. A 2 and a 3, or a 1 and a 4, which could be 5, and so on. We could get a 6 by getting a 1 and a 5, or a 2 and a 4, or a 3 and a 3, or a 4 and a 2, and so on. We could get a 6. And the highest value we could get to 12, because whenever you roll a 6 and a 6, that's 12. So the possible values we could get would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or 12. And they're all the possible outcomes. Whenever you roll two dice and add the scores together, there'll be our possible outcomes. Okay, so our next topic is sample spaces, and here we've got a sample space question, and it says the counter is picked at random from each bag. So we've got two bags, bag 1 and bag 2. In bag 1, the counters have the numbers 2, 1 and 5 on it, and in bag 2, the counters have the numbers 4, 3 and 2 on them. And it says the counters picked at random from each bag and the numbers are multiplied together. And we've got this table, and this will help us find all the results. So we've got bag 1, and in bag 2 we've got 2, 3 and 4, and the numbers are being times together. So we could get a 1 and a 2, well 1 times 2 is 2. We could get a 2 and a 2, well 2 times 2 is 4. We could get a 5 and a 2, well 5 times 2 is 10. We could get a 1 and a 3, well multiplying those together is 3. A 2 and a 3, well that would be 6, multiplying them. 5 times 3 would be 15, 1 times 4 would be 4, 2 times 4 would be 8, and finally we could get a 4 and a 5, or 5 and a 4, and that would be 20 when we multiply them. And the question says, what's the probability of getting a multiple of 4? Okay, so let's look at our outcomes and see which ones are multiples of 4. Well, 2 is not a multiple of 4, 4 is a multiple of 4, 10's not, 3's not, 6 isn't, 15's not, 4 is, 8 is, and 20 is. So out of our 9 possible outcomes, 4 of them would be multiples of 4. So a probability of picking a multiple of 4 would be 4 out of 9, or 4/9, and that's it. Okay, let's have a look at our next topic. So our next topic is called relative frequency, or sometimes called experimental probability, and that's video 248 in Corbettmaths. So here we've got some letters, and I've done an experiment where we've picked a letter at random from the letters A, B or C. And the letters picked at random were, and I've done it 7 times, were A, B, A, C, B, A. So a letter's been picked at random from the letters A, B or C, and we've done the experiment 7 times, 1, 2, 3, 4, 5, 6, 7 times, and these are our results. So if we were asked to find the relative frequency or experimental probability of an A, we just write down what fraction of our results were A's. So as there were 7 altogether, it would be out of 7, and there's 1, 2, 3, 4 A's. So the relative frequency of an A would be 4 sevens. If we were asked to find the relative frequency of a B, well, we've done the experiment 7 times, so it would be out of 7. And there's 2 B's, so the relative frequency of a B would be 2 sevens. And if we were asked to find the relative frequency of a C, it would be 1 7th, because there's 1 C out of the 7 results. Okay, so relative frequency or experimental probability is just found by writing the number of successes over the total number of trials. Okay, let's have a look at another type of question now. So this time we've been given a table, and we've got 2 people, Susan and Helen, and they've done an experiment. And Susan's done the experiment 20 times. She span a spinner 20 times, and on that spinner there's different letters, and we're told the number of B's that she got whenever she span it 20 times was 8. So if we're asked to find the relative frequency of spinning a bee, so because she spun the spinner 20 times, it would be out of 20. And because she got 8 bees, the number of successes is 8, we write 8 out of 20, or 8/20, like so. We could write this as a decimal, or we could even simplify our fraction. Simplifying our fraction, we'll divide both of these by 4 would give us 2/5. So we could write an answer of 8/20 or 2/5. If the question doesn't tell you to simplify it, we don't have to, so we could just write 8/20. Alternatively, because Helen's result is a decimal number, we could also give it as a decimal number. We could write, well, 2/5 as a decimal will be 0.4. Okay, let's look at our next person, Helen. And Helen spun the spinner more times. She span it 120 times. And this time we don't know how many bees she's got, but we know the relative frequency of her getting a bee. We know the relative frequency is 0.35. Now, to find the number of bees that Helen got, all we need to do is multiply the relative frequency by her number of spins. Thinking back to M5, we had a topic called expectation, where to find how many times you expect something to happen, you just multiply the number of trials by the probability. So if you multiply the relative frequency of the experimental probability by the number of trials, it'll tell you how many successes you had. So if we multiply 120 by 0.35, that will tell you how many times Helen's spinner landed on a bee whenever she span it. So that would be 42. And that's it. Okay, let's have a look at our next topic. So our next topic is called samples, and that's video 281A in Corbettmaths. Now, if we were doing a survey, rather than surveying everyone, which would take a lot of time and cost a lot of money, what we often would do is we would often take a sample, which means that we choose a smaller amount of people to survey rather than everybody. Now, samples can be fantastic because it can save us time and money, but one important thing to consider is, are they reliable? Are they going to be representative of everybody? Okay, let's have a look at our question. So Tilly wanted to do a survey about homework at her school. So she wants to do a survey of homework at her school, and she's interviewed 5 students in her class with the highest test results. State 3 improvements Tilly could make. Tilly's done a survey about homework at her school, so it looks like she wants to get the opinions of everyone at her school. Now, she's only surveyed 5 people. So one improvement is she could survey more people. I think a survey of just 5 people is a bit too small. Okay, another improvement. It says 5 students in her class. I think she should really survey a range of classes or year groups. So because she surveyed just students in her class, you know, those students might not be representative of the whole school. Different year groups might have a different opinion to homework. Different classes, you know, might have different opinions and so on. Okay, it says 3 improvements. Another one would be as well, it says she surveyed 5 students with the highest test results. I think she should survey a range of abilities. Rather than just picking the students with the highest test results, because it's a survey about homework, they might have a certain opinion on homework that other students might not have. So that's it. So it's important whenever we take samples that, you know, samples are representative of the whole population, and also to make sure particularly that you're surveying enough people. So whenever you're taking a sample, it's important the sample is bigger, and the bigger the sample, the more reliable it is. But obviously that will have then implications in terms of time and cost and so on. Okay, next. Okay, let's have a look at our M6 number topic. And on our revision checklist, we've only got one number topic here, which is binary. We're going to look at how to write binary numbers as decimal numbers and how to write decimal numbers as binary numbers. And this is video 398 in Corbettmaths. So our first question says, write the number 1101 as a decimal number. If we want to write this binary number as a decimal number, I start off by writing down these column headings where I write 1, and then times by 2 is 2, times by 2 is 4, times by 2 is 8, times by 2 is 16, and so on. And then I write this number, this 1101, in this table. So I start off with 1011. And then if I want to write this binary number as a decimal number, all I do is then I add together a 1, a 4, and an 8, because I've got 1, 1, no 2s, 1, 4, and 1, 8. So if I add together the 8, the 4, and the 1, so 8 plus 4 plus 1, 8 plus 4 is 12, plus 1 is 13. So if we had the binary number 1101, that's 1, 1, no 2s, 1, 4, and 1, 8. And then when we add those together, we get 13. Let's have a look at our next question. So our next binary number is 10110. We want to write that as a decimal number. So again, starting off with 1 and multiplying by 2, we get 2, 4, 8, 16. And we've got 1, 2, 3, 4, 5 digits. So we've got enough columns. That's great. So we can write 0, 1, 1, 0. So that's 10110. And that means we've got no 1s, but we've got a 2, we've got a 4, we don't have an 8, and we've got a 16. So if we do 16 plus 4 plus 2, we'll find our answer. So 16 plus 4 is 20, plus 2 is 22. So the binary number 10110 is 22, and that's it. Okay, now let's have a look at how we would write decimal numbers as binary numbers. So I start off with 1 and I multiply by 2 to get 2, 4, 8 and 16. And we want to write the number 18 as a binary number. So I've gone up to 16 because I don't need to go to 32 because we're writing 18 as a binary number. We don't need to go up as high as 32. And if we want to write 18 as a binary number, well, we want to get 18, so that's going to be a 16. So we could use a 16. We don't want to use an 8 because if we had an 8, 16 plus 8 is 24, so that's too big, so we don't want to use an 8. A 4, but we don't want to use a 4 either because if we've got a 16, adding 4 would be 20, so we don't want a 4. A 2 would be useful because 16 and a 2, well 16 plus 2 is 18, that's fantastic, and we don't need a 1. So we would have a 16, no 8s, no 4s, a 2 and no 1s. So the answer would be 1, 0, 0, 1, 0. So 18 as a binary number would be 1, 0, 0, 1, 0. Okay, and our next question says to write 27 as a binary number. Well, we don't need another column because that'd be 32 and that's too big. So 27, well, let's use a 16. Now moving to our next column, well, that's an 8. Well, 16 plus 8 is 24. So yep, let's use an 8. It gets us closer to 27. So 16 plus 8 is 24. Now 4. Well, 24 plus 4 is 28. That would be too big. We want to get 27, so we can't use a 4. A 2, well, 16 plus 8 is 24, plus 2 is 26. That's great, let's use that. And a 1, well, that'd be 27. So that's it. So 27 as a binary number would be 1, 1, 0, 1, 1. And you can just test it by adding together 16, 8, 2 and 1, and adding those together would be 24, 26 and 27, and that's it. So this video has been the ultimate M6 revision video. The aim of the video has been to spend about 5 or so minutes in each one of the M6 topics to make sure that you're familiar with it. So this revision checklist, remember this is in the description below and it's really useful if you do need to go through any of the topics in more detail. If you go to those video numbers on Corbettmaths, you can watch a 10-15 minute video on each of those topics. And remember there's practice questions and textbook exercises beside those as well. Also remember for M6 it's important to know the M5 topics and also make sure that you're familiar with the M2 and M1 topics as well. Also, as you've been going through this video, you may be writing notes as you've been going through each of the topics, and that's important. But also remember there's the Ultimate CCEA M6 Revision Question Booklet, and it can be found in the description below. And there's questions there in every single topic as you're going through this video. The QR code will bring you to the answers. Also, as we've been going through the video, I've borrowed lots of the revision cards. The revision cards can be found on the website and in the description below. They can be really useful. For M6, you'd want to get the foundation set, and that'd be really useful for you. Also for M6, the 5-a-days can be really useful. That little and often approach to doing revision, spending 5-10 minutes on your maths every single day can make a massive difference. So for M6, I'd recommend the Foundation 5-a-days, the orange book, and I'd also recommend the Foundation Plus 5-a-days, which is the yellow book as well. I really hope you found this video useful. This has been the ultimate CCEA M6 revision video going through those M6 topics. If you do like the video, please click that like button. Please subscribe to the YouTube channel, and all the very best of luck with your studies. Good luck.